Hey guys, it's Casey and I am back with I believe we're on 4 now, of our tower defense tutorial. And what I like to do after I've been recording each of these videos is that after I've finished, I'd like to go back and watch it. And in rewatching the last episode, the last video, I noticed I made some mistakes inside of our projectile. So if we want to open back up our projectile, I messed up the code right here. I put a big old whoops because I made a whoopsie. So what I accidentally did here is that right here on this set, we don't want to be setting this interpolate, because if you remember, this is the location that we're setting our actor closer and closer to our target on every tick. What we wanted to be storing was the last known location of our target. And here's our target, here's our get actor location. This is the location that we want to be setting, and we want to hook this back up to our set actor location. So what was happening before, which I believe I barely noticed it in the last video, is that when our target was dying and we had a projectile in air, our projectile was just freezing in place and then just existing in the world. So we had two issues. One, we weren't storing this location properly, because what we were doing is we were then, after the target was dying, we were homing our projectile to the location that our projectile already was, so it's just sitting still. And then the other issue is, after our projectile does hone to this last known location, we're not doing anything with the projectile. Our projectile will just go to that last known location and then sit there. So we want to do one more thing, and what we want to do is that, I think the best way of doing this is that what we want to do is that on this not valid, so the logic will be on tick, if our target has died, we want to hone to our target location. However, we want to check whether or not we are at our target location yet. So the way we're going to check to see if we are at our target location yet is that we want to take the actor location of our target, the actor location of ourself, and then we just want to subtract the two of them, because once again, that gives us a line with the magnitude of the distance between them, and that we want to get the length of this vector. And let's just check, are we closer than, let's just say, are we closer than 20? That should be fine. I don't think that should ever fail. If we ever have issues to where our projectile is getting to our end location and then just sitting there, we might need to increase this, but the way that we're getting closer by using this interpolation node, I believe this should never be an issue. So what we want to do is on tick, if our actor is dead, we want to hone towards our target location. However, before we start homing towards it on each tick, we just want to check, are we closer than 20 units to our actor? And if we are closer than 20 units to our actor, let's destroy our projectile. Later on, when we introduce splash damage, we can do that here. However, if we are not closer than 20 units, if our distance between our two actors is not less than 20, we are just going to keep homing towards our target. So I believe that should fix the issues that we had in that projectile. Let's think it through. Yep, we are storing the last known actor location. We are now going back to using the interp, and down here we are interpolating. If we want to bring that a little bit closer, we are interpolating between our actor and the last known location. That looks good to me. We are subtracting ourself and our target, getting the length less than 20. That looks pretty good to me. Let's just make sure. Returns true if A is less than B. That looks good to me. If we are, we're destroying. Okay, that looks good to go. I just want to make sure I don't fumble that code anymore. So what we want to do in this video is we want to expand on our tower. So what we have our tower currently doing is that when something enters the overlap of our target inside of its range, we check to see if we currently have a target. If we don't have a target, we're going to set our target. And then on tick, if we do have a target and we're not reloading, we're going to be shooting. But then right after we shoot, or I guess right before we shoot technically, we're going to set ourselves to reloading. And then after a delay that comes from our data table, we are then going to stop reloading, and then that will allow us to shoot again. So we have an issue in that we're only acquiring our targets currently based on when they enter our overlap. So if we could set this up, let's see if I can set this up in one try. So let's set up our sniper tower. So let's do our chair. So let's go back and let's look here. So we have our chair. And then let's put it in this corner so it has a huge aggro radius. We're going to set it to be our chair. Let's go inside of our AI runner, and let's have our AI runner die in one hit. So what I want to do here is I want to set our AI runner to have a health of, let's just set it down to 5. So now our runner will die in one hit from the tower. And then what I want to do is I want to go into our spawner, and I want to spawn 2 enemies back to back to each other. So what I want to do is on begin play, I want to spawn 1 runner, and then what I want to do is, just for our purposes, I would do this a different way, and we will set up our spawner to be more complex. I just want to run this code twice, so I just want to delay real quick. I'm going to delay, let's just do it by like half a second just to separate them very, very, very slightly. And then let's have the second runner spawn, and they will both chase. And what I want to show here is that since we only acquire our targets based on the moment they enter our overlap, if we have our first runner enter the overlap and we target and start shooting, if we kill our target while our second runner is already inside of the overlap, we have no way of targeting that second actor. So let's show it here. So if we hit play, we have our 2 runners. We should shoot at the first runner, kill it in one hit, but then you see here, we're not shooting at our second runner. And the reason being is, as I said, the only way that we are acquiring targets right now is based on our overlap. So what we need to do is, if we find our tower, here we are, what we want to do is we want to try and find additional targets. So let's delete this. Alright, so the way we want to do that is, I know we pretty much want to do this on tick. There could be other ways of doing this, but I could foresee some issues. If you think about our end code is just going to be some new type of target acquisition within our range, in theory, we could check to see when our target dies. In theory, we could set up a way to where when we kill our target, we immediately run our like find new target, and that we would never have to do this on tick. But I could potentially foresee some certain situations to where potentially we don't know when our target dies, or if we add some like special functionality of like our target going like invisible, there could be some weird situations to where we need to be able to check for a new target whenever we can, like whenever we want to, not just at like the death of an actor, I guess is what I'm trying to say. So for me, I know I pretty much want to do this off of tick. So what I want to do is on tick, if we do not have a valid target, we are going to search for a new one. So what we want to do is, if we do not have a valid target, we are going to do a custom event. So let's make a new custom event just like we did for shooting, and we're going to say check for target. Let's do check for new target. Let's do that. So we're going to do check for new target, and for me, it's just kind of intuitive for me. Since our aggro range with the overlap is a sphere anyways, I'm going to bring it up again, I feel like I'm really beating a dead horse. In the video where I talked about the 3 main concepts to understand for blueprints, I showed off line traces, and we used a line trace to get an actor reference and to stop our cube from spinning, is what we did in that video. Well, there's different types of traces, and what traces are useful for is getting actor references. And what we can basically do is we can do a sphere trace, just like we are doing to get an overlap, but we can use a sphere trace to get whatever is inside of the sphere. So let's do that. So on our check for new target, what we want to do is I feel like I just fumbled my words. We want to draw a debug sphere. And with this sphere, we want the center to be at the location of our tower. So we don't actually need to do that. We can just do get actor location. And then we want the radius to be equal. If we get our tower struct and we break it, we want this radius to be equal to our tower's range. Line segments, we probably don't need to be concerned with that at all. I mean, if we check our sphere, does this have line segments too? I don't believe the overlap sphere deals with line segments. It doesn't look like it, so no, we're not too concerned about that. If our overlap sphere had some type of setting for line segments, I would just make them equal to each other, but our sphere doesn't, so I'm not worried about that. So let's make, for debug purposes, let's just set it to be bright pink so we can see it. Yeah, pink works. Oh, I am not doing this right. We are not drawing a debug sphere. What am I doing? We don't want to be doing a debug sphere. We want to be doing a trace sphere. A sphere trace, my bad. Sphere trace for objects. My apologies. We were using the wrong node temporarily. So this is much better. So now we don't have a setting for segments. That was very bad of me. So the start of it is going to be our actor location. And one thing I'm actually not sure about is if we pump the start and end location to be the same exact spot, I don't know if the sphere trace will actually work. So instead of testing it to find out, which may be a good idea in the future, I'm just going to subtract 1 off of our z and make that the end location. So we're pretty much just drawing the sphere, moving it down 1, and that's our end point. And then what we want to do is we want to punch our the range into the radius, and then we want to take our object types, we want to make an array, and we want to check what our AI runner is. I'm just going to assume our AI runner is a pawn, but let's check. Collision presets, it is object type of pawn. So we want to say the object types that we want to search for is just going to be pawn. And then we don't need to ignore anyone, we don't need to trace complex, we're fine there. And so let's do a debug. I think you guys will understand. I don't think we need to draw debugs on this. I think it's pretty clear what we're going to try and do. So what we're doing is on tick, if we do not have a target, we are going to check for a new target. To do so, we're basically going to exactly mimic what our overlap sphere is doing. We're going to draw a sphere just like this in the same location with the same radius, but instead of an overlap sphere just checking the moment when something comes inside of it, we're going to check what is actually inside of it. And then if we have some hits, if we do hit some things, we always want to do branches after traces. If we do hit something, so on true, what we want to do is we want to break. I did the wrong node once again. The reason why I know I did the wrong node is that this will only check for a single target. I guess this is a good learning experience. When you do a normal trace, this is just a normal sphere trace, this is only going to check for a single object. The first object that it hits in this trace, the trace will just end and it'll be like, I did my job. What we want is if we search sphere again, we need a multi-sphere trace for objects. And what this is going to do is if you see this out hit on our normal trace, we only get a single hit result. On a multi-sphere trace, we get an array which holds many hit results. So this will find all of the actors, while this is just going to find the first actor that it hits. So what I'm going to do is I'm going to show you something cool that I like to do. We could just like unhook these nodes and delete this. If I hold control on my keyboard and I click on these nodes, you'll see I get like a little grabby, or like a little grabby. And I can just basically just very quickly grab them down, copy over what we had, just hook everything back up, and now once I have all the pins gone, I can delete it, and this is exactly like we had before. So with the multi-sphere trace, we get out an array. An array is just multiple hit results. So what we can do with this array is we want to do a for each loop on top of it. Looping is going through something multiple times. There are many types of loops. There are while loops, there are normal for loops. Do we have any more types of loops? There's for each loops. This probably handles most of it. A while loop is we can feed in a boolean and we can just basically say while a certain condition is true, keep going through whatever logic we have on this loop over and over and over and over until finally this condition turns false. And then once this condition turns false, we will stop looping and we will go onto our completed code. That's a while loop. A for loop loops through a certain set amount of times. So we could say 1 to 10, and that we would loop on 1, we would run our loop code, then it would come back and it'll say, do we have another loop to do? And it would hit to 2, and it'll say, yep, that's within this range. Do our loop code, then once it finishes, it would go to 3 loop, and it would do that until eventually it hits index 11. It's like, can we do 11? It says, no, our last one was 10. It'll stop doing this looping code, and it will do this completed code. A for each loop is going to loop through the amount of hit results that we have. So if we turn out we only have 1 hit result, this loop code that we have right here on this loop body, it will only run this code once before going to completed. If we have 10 hit results, we'll loop through this code 10 times before we go through this completed. So loops I'll show you what loops are really good for. And what we are concerned about is normal tower defense logics is that when you kill your target, your next target, if you have like a bunch, say there's 11 targets within our range, one of those is our current target, we kill that current target, and now there's 10 targets remaining in our range. What we need to find out is which of those targets is the closest to our tower. That is normal tower defense logic. So with all of these hit results, we now want to find which one is the closest. And how we're going to do that is we're going to loop through all of our targets. So what we're going to do here is, should we actually make this a function? This could be a good opportunity to use a function. So let's actually use a function. So what I'm going to do is I'm going to delete this for each, and I'm going to make a new function real quick. So let's make a new function, and we'll call this closest target calculation. So what we're going to do is we are going to make an input, and we are going to search for hit result. And then on top of making it a hit result, we want to use this pin because this means it's a single variable. We want to go down to an array. And now let's call this our hit results. And now what we can do is we can work with these hit results, and we can do that for each loop. The reason why I want to put this in a function is because we're going to be doing some certain amount of math inside of here. And with this math, we're going to be using some variables. We don't need access to these variables anywhere else. They just need to be existent in this function, and then we're done with them. I talked about this in that video. I'm going to keep referencing the three most important things. We talked about using local variables, and that's what we want to be using here. So for each of our hit results, for each of our runners, or for each of our hit results, we haven't gone that far yet, we want to make sure that each of them are actually our runners. So once again, we're going to cast to runner, because our sphere, if you go back to our sphere trace, we're just searching for pawns. We're searching for any pawns within our radius. We don't know whether or not these pawns are going to be runners or not. That's why we need to cast off of our hit result on each of the actors. So if the actor is a runner, what we want to do is we want to check if we currently have a target. So let's make a local let's promote this to a local variable. So you see here when we're inside of a function, we have local variables. Let's call this our temporary target. So we'll call this temp target. And what I want to do is I want to check, hey, if this is a runner, do we currently have a target? If we do not have a target, let's make this first person that we're looping the first runner that we're looping through, let's make that our target. And then if we already have a target, what we want to do is we want to see, is this new target closer than our old target? So what we'll do is we're actually going to do a calculation here. We want to find distance. How do we find distance? We subtract the location of the two actors. So let's get the actor location of ourself. And what we'll actually do for some... No, that's not... No, we don't want to do that. What we'll do is we'll get the location of our tower. Let's subtract out the location of our other actor. So we have our self, we have the runner. What we want to do is we want to get the length of that vector. And now let's promote this to a variable, promote to a local variable, and we'll call this distance temp, or we'll call this temp distance. So if we think about this code, what we're going to do is say we have 10 hit results. What we're going to do is we're going to loop through all 10 of the actors that we hit. One by one, we're going to go through the first actor, or the first hit result. We're going to say, hey, are you a runner? If you are a runner, we're going to check, hey, do we currently have a temporary target? The first actor that we go through, or the first runner that we go through, this is not going to be set. So obviously, the first runner that we go through, this will not be valid. So we're going to set our temp target to be that first runner, and we're going to store how far away is that runner. Then what we're going to do is it's going to come back to our code because we're looping. It's going to hit the end of the code, and it's going to come back. And on our second runner, we're going to run through the same exact code, and it's going to say, okay, for the second guy, are you a runner? If you are a runner, do we have a target? For the second guy, it's going to be like, yes, we do have a target. And what we care about is the second runner closer than the previous runner, or the previous stored runner? So what we want to do is we want to then reuse this code. We can just reuse it. That might be a little complicated, but since we're looping, this is an entirely different calculation with the second loop. And we're going to check, is the second runner less than the first runner? So is the distance of the second runner shorter than the distance that our first runner was, or the currently stored runner was? If that distance is shorter, what we want to do is we want to then set our temporary target to now be this new runner, and after we set this new runner to be our target, we want to store his distance, and that will just be this same calculation. So if we run through this code, let's once again think about we have 10 targets. So we do this sphere trace, it comes back with we have 10 runners within our range. The first runner comes in, we make sure he's a runner. If he is a runner, our temp target is obviously not set yet. So what we're going to do is, since it's not valid, we're going to make that first runner our target, and we're going to store how far away he is from the tower. Then we're going to come back, and it's going to come back, and it's going to go, okay, for the second runner, are you a runner? Yes, you are. Okay, do we have a target? Yes, we do. Are you closer? Is your distance to our tower closer than the distance that we stored for that first runner? If he is, then what we're going to do is we're going to say, hey, that first runner, you can go away now. This new guy, he's our man. So we're going to set him as our target, and we're going to store his distance now to be our temp distance. Then our code's going to come back, and it's going to do this for every subsequent runner. So for our third runner, or let's say our seventh runner, it's going to come back. We're going to say, hey, are you a runner? If you are a runner, do we have a target? Yes, we do. Are you closer than the distance we currently have stored for the closest runner? If you are closer, then you're now our guy, and so on and so forth, until finally it loops through all of our hit results. And then what we have is we have a completed node. So once it finishes looping, instead of going through this loop again, it's going to come down and we have our completed execution pin. And then what we just want from our outputs, if we click on the name of our function, it pulls up our inputs and outputs. What we want to then do is we want to do a output, and we want an output of our runner AI, our AI runner. And then we need to not make this an array. We just want this to be a normal single variable. So now we have our return node, and then on completed, we just want to return our target, and our target is going to be the closest target that we have stored. If this code was a little confusing for you, I tried to run through it step by step. You use loops a lot. Loops are what you use when you're sifting through a lot of information, or you need to do something multiple times. And really what this code does is it just tries to find, of all the runners within our range, who is closest. Whoever is closest, we're going to make that our target. And then what we can do now is we can call this function. So if we go back to where we were doing our check for new target custom event, I need to drink for a second. We can then drag in the function that we have. As long as we have hit results, we want to run our function. We need to hook up the output of our arrays into the inputs of our function. And then our function didn't update yet. Let's hit compile. Does it give us an error? So whenever you make changes within a function, like name changes to that variable, if you don't compile, you're going to get an error because it's like, hey, that output pin isn't what I think it should be. So we just need to recreate it real quick, and you'll see how it changed to the name. So now if we recreate it and we hook it up and we compile, we don't get an error. That's just a little bit of an annoying thing with blueprints. So now, if we need a target, let's run through the code. On tick, if we currently don't have a target, we want to call our custom event, which is check for new target. And when we check for a new target, we're going to do a sphere trace, perfectly the same as the tower range. And then what we're going to do is, if we do have some targets within our range, we're going to loop through them, and we're going to make sure we have a target. I could foresee an issue here in that, say, there's no pawns within our range, because that's what we're searching for. We're searching for pawns. This will come back false, and that's okay. But let's say there is a single pawn within our range, but it's not a runner. That means that what this will return, this whole function here will return, it will return none for our target, because as it loops through, it's going to hit, is that pawn a runner? It's going to go cast failed, and then it's just going to loop to the next actor. So this temp target, if the only target we have within our range is a pawn that is not a runner, this will come back false. So the one thing I want to check back is just, is this valid? If we do get a valid return target, we want to then make the target of our tower equal to the target that that function returned. So, and then if you think about this, say we have a target, we loop through, we shoot at him, we kill him, it comes back, and then it says, hey, we don't have a valid target, we check for a new target, and then in our check, it comes back with a new target. You see here that we're setting our tower target to be a new fresh actor. On tick, it'll come back and it'll say, hey, we have a new target, let's shoot at him. So that's kind of the logic here. There's one other thing I'm concerned about, and it is that tick runs a lot, as I've talked about before. It's called every frame. Potentially, let's say we're like between levels, or let's just say there's a huge gap in our level between our tower and where our runners are. That means that we would be running this sphere trace potentially a ton of times a second to try and find a new target. We don't want to run this that much. We want to run this a pretty much a less often. And how we can do that is we can set it up just like our shooting code. We can promote a new variable, we can make it a boolean, and we can say check for target delay. So we'll just call it check for target. And what we want to do with this boolean is that when we are checking for a new target, let's set this to be true. And that once we finish checking for our target, what we want to do at the very end here is we want to set this check for target back to be false. There's one thing we want to make sure we do here, in that if we're setting this to be true, we need to make sure that whatever code comes after this, no matter what the outcome is, we're always going to be setting this to false. That means we have multiple outcomes here. If we do our sphere trace and nothing is within our range, we need to make sure we set this to false. So for some clarity purposes, for some visual purposes, I'm just going to copy paste that code. So if we do our sphere trace and we don't hit any results, we need to make that back to false. If we do an is valid check and nothing comes back valid, we need to set this to false. But there's one more thing we need to do, and we need to delay. So what we're going to do is I'm actually going to delete all of this since I was trying to do that for some clarity purposes. What we want to do is I'm going to drag this slightly down, and just like our reload code, we're going to add a delay. 0.2 is fine for me. So what this means is that if we kill our target, we're only going to be doing this check 5 times a second, or 0.2. To me, that's okay. If we set this to be like once a second, it might be irritating for a player that your tower kills a target and then it waits like an entire second. That could be annoying. I'm more okay with 0.2, or we could even make this 0.25 so it checks 4 times a second. I'm okay with that. And then what we need to do is we need to take the pins that we deleted off of and just make sure that no matter what the outcome is after this, we always set our check target back to false. And then we just need to go back to our on tick. If we do not have a target, we want to make sure that we are not checking for a target, and then we set that to be true. So if we run through our code, on tick, if we don't have a target, and we're currently not checking for a target, so we need to set this to be false. If we're not checking for a target, run the check for target, and then when we are checking for the target, we're setting that to be true, so that on tick, it's going, okay, we are checking, I can't run this custom event. And then at the very end, after a 0.25 second delay, we'll set that back to false so that it can once again check for a target. But remember, this code will only run as long as we do not have a target. So what this should now do, if we run our code, if you remember what happened before, is the first runner ran in, the second runner right behind. When we killed the first runner, we did not target the second runner because it was already inside of our overlap. If we hit play, that should now, after it kills the first target, it should immediately start shooting the second target. And there you go. There is a small delay there, and that delay was actually the reload time on our gun, on our tower. So if you remember, on reload, our chair tower was only shooting once every 2 seconds, so that was the delay there. It was finding the new target, but it had to wait till it was finished reloading to shoot. So that handles a big gap in our tower logic, and let's think for a second. Is there any more holes in our logic? I'd like to say that's pretty good. We're acquiring targets when they come in our range, we're shooting at them. If they're killing them, we're finding a new target. That seems pretty good to me. So what we can do, let's see, how long are we in? We are 30 minutes in, and let's actually stop the video there. I'll make it so that this isn't another like 40-minute video. So for this one, all we did is we fixed our projectile and we set up new targeting logic. I probably over-explained that a bit. I'm trying to take my time for you guys, and I'm trying to really over-explain it a bit. And I'm trying to explain my logic and why things work, and I really hope that pays off for you guys. Once again, leave me any feedback. If you feel like this is too slow and you're like, man, you're beating a dead horse, just get on with it, let me know. This is the first tutorial I've ever done, so I'm not sure how much I'm beating a dead horse on some of these topics. So if this is helpful for you, please let me know. And if I'm too over-explaining things, that's fine too. Please let me know. So I will see you guys in the next video.